Assalamu alaikum everyone. Welcome to Mathematics with Shahab Yaqub. So now some of you have a midterm exam tomorrow. Some people have a midterm exam sometime during this week. So now the final class for that S1 preparation, this is about DRV, discrete random variable. So let's get started with that. Let me start the recording on the Zoom also. So first of all, the recording is there, and I think everyone can hear me clearly. Let me first share the screen. So that is the thing. And you can see the screen right over there. So now let me start the recording on this cloud. So we are starting with the review of DRV, that is called discrete random variable. Now binomial distribution and geometric distribution, they are also part of DRV. Now before that, the question is, what exactly is DRV? Now DRV stands for discrete random variable. That means you are talking about a variable which can be counted. So the word discrete over here, it means counted. This is not the other discrete, discrete. So that is the one in which that is about being quiet, just be discreet, just keep it low profile. That is other type. This one is counting. So any variable which can be counted, whether it's about number of heads or it could be about number of rainy days, it could be about number of red cards. All these things are discrete random variable, and money is also one of them. So it's not just about integers, it's about the idea that anything that can be counted. Why do we use the term random? We use the term random because everything is taken into consideration. Sum of probabilities equals to 1. This is the summation notation. Integration is also summation. The sigma is also summation. We are interested in sigma. Sum of probability is 1. And that is one of the things that is used a lot in these questions, especially those questions that are related to table. Someone has asked this question, so will you be covering binomial distribution 2 in the class? The answer is yes, I'll be covering binomial distribution, and it will be an overview, inshallah. I hope it will be helpful for you all. So now when we are talking about binomial distribution, let me first write down the conditions for binomial. So for binomial, there are certain conditions that needs to be fulfilled. What are those conditions? The conditions are the number of trials are fixed. Now, what exactly is number of trials? For example, if we are talking about, let's say, the number of rainy days, and that is one of my pet examples that I use, the number of days on which it rained, let's say we are talking about a week. So it could be 0 day, 1 day, 2 day, 3 day, 4 day, 5 days, 6 days, 7 day. So that is the number of trials. 7, we are talking about 7 days. 7 is the number of trials, and there are 8 possibilities. So number of trials is fixed, and the number of trials, they are independent of one another. The probability that it rains on a particular day has nothing to do with raining on the next day. And the third condition is that the probabilities are fixed. They are constant. They cannot change. That means a scenario in which we are talking about without replacement, that cannot be categorized as binomial. So keep it very, very separate. Now in geometric, as such, they don't talk about the conditions. But what we can say is that the number of trials are infinite as opposed to fixed. So that is the litmus test that differentiates between whether it is a binomial distribution question or a geometric distribution question. The next thing, the probabilities are constant. So this is also here. The probabilities are constant. When we talk about binomial, we say that X follows a binomial distribution with two parameters n comma p. And this is kind of distracting. So let me throw this out for right now. So I'll just try to grab this. I don't know, some issue. So let me just push this down and let me push this down. So now over here, X follows a binomial distribution. It's based upon two parameters, that is n and p. Whereas when we talk about geometric, X follows a geometric distribution and it's only based upon one parameter, that is p. So there is n and there is no n because n is infinite. Okay, the next thing. What about the formula? Probability X is equals to R, that is NCR. Success raised to power of R, failure raised to power of n minus R. That is the formula that we use. Over here, probability X is equals to R. As soon as you achieve success, you stop. Remember my words. As soon as you achieve success, the process stops. Whether it's about a rainy day, whether it's about getting a particular red flower or something, process stops. So therefore power of P is 1, whereas power of Q is R minus 1. And let me take this a little bit further down the road. So now over here, I need something. And over here, I'll write that expectation of X is NP. That is the expected value. That is the mean. That is the expectation. Whereas the variance of X is NPQ. This is variance. You just need to use it. What about geometric? Expectation of X is the reciprocal of probability. Remember these words. Now these two things over here, they fall under the category of geometric. These are shortcuts, legal shortcuts that we use. This is probability X greater than N. So we will use this thing. And over here, we have probability of X lesser than or equal to N. We will use this. So that is this thing. X is lesser than or equal to N. That I can write as X is at most N. That is, it could be N, it could be lesser. Keep the two things in handy. We know that P is the probability of success, whether we are talking about binomial or we are talking about geometric. This is probability of success. And Q is probability of failure. And we know that P plus Q adds up to 1. So that is the basic theme that we use. And this is about discrete random variable. Now let's look at this question. I want you to read the question first. And it says, this is from 2020. It says, in a certain large college, 22% of the students own a car. So let me highlight this. 22% of the students own a car. And then it says 3 students from the college are chosen at random. Find the probability all 3 students own a car. Now, how do I know whether it's a question of binomial, whether it's a question of geometric? We are choosing 3 students. When we are choosing 3 students, 3 is the number of trials. And the number of trials, if it's given and if it's fixed, that means it's a binomial probability question. That is the thing by which you check whether it's a question of geometric or it's a question of binomial. So you will write X follows a binomial distribution 3, 0.22. That is the probability of success. All 3 students own a car. Probability X is equals to 3, that is 3C3. And this is success raised to power of 3. This is failure 0.78 raised to power of 0, which is 0.22 raised to power of 3, which is common sense. The success is 22% and for the other one 22% and for the other one 22%. So 0.22 into 0.22 into 0.22. That comes out to be how much? That comes out to be 0.22Q. All good, all clear? Now the next thing, that is this one. 16 students from the college are chosen at random. Find the probability the number of students who own a car is at least 2 and at most 4. Now, at least 2 and at most 4, let me draw a number line over here. And 0, this is 1, this is 2, this is 3, this is 4, this is 5, all the way till 16. So at least 2 and at most 4, that means greater than 2, greater than or equal to 2, lesser than or equal to 4. So this is greater than or equal to 2, lesser than or equal to 4. So also include 3. So just choose this thing. And now the number of trials is 16. So we will write X follows a binomial distribution 16, 0.22. Probability X is equals to 2. That is 16C2. And probability X is equals to 3. That is 16C3. And probability X is equals to 4, that is 16C4. So now the thing is, when we do this thing, make sure that you write down the template first and then fill in the values. So now this 16 over here, let me write it properly. Now that's a very big eraser. So this is 16. So now this success 0.22, that will go over here. Make a pattern for yourself. This is 0.22 and the power would be 2, 3 and 4 respectively, 2, 3 and 4 respectively. 0.78, that is failure probability. And the difference between 16 and 2 is 14, 16 and 3 is 13 and this is 12. The sum of powers should equal to this thing n. 14 plus 2, 13 plus 3, 12 plus 4. And now we will calculate all these 3 probabilities. And we will add it all up. So when we add it all up, let me look at the mark scheme. That is over here. That is 16C2. That is 16C3. That is 16C4. These answers are written separately or use a calculator and write everything over there. And this is the answer, 0.631, correct to 3 significant figures. So that was a straightforward question related with binomial. So let's move ahead. Now read this question again, a new question. Now the question is, Ramesh throws an ordinary 6-faced die. Find the probability he obtains a 4 for the first time on the 8th throw. Now, when we are talking about this thing, did they mention that there are number of trials? So first of all, number of trials is not mentioned or not given. And the question is about Ramesh throwing an ordinary fair 6-faced die, 6-sided die So probability of getting a 4 is 1 over 6. So probability of success is 1 over 6. And this person achieves success. He obtains a 4 for the first time on his 8th throw. That means there were 7 failures. 1, 2, 3, 4, 5, 6, 7, and the 8th one is a success. So therefore, failure is 5 over 6 multiplying by itself 7 times, and success is 1 over 6. This is basically geometric. X follows a geometric distribution with 1 over 6. Probability X is equals to 8, that is 1 over 6, and 5 over 6 raised to power of 8 minus 1, which is 7. So I have done it in 2 different ways. Either I consider it to be geometric, which it definitely is, and use the formula, or I just use common sense and reach success on the 8th thing. So this is all good, this is all good, all good, all clear. Now let's move ahead. The second part. Now it says find the probability that it takes no more than 5 throws for Ramesh to obtain a 4. So success is still 1/4. No more than 5. What does that mean? So no more than 5, that means probability of at most no more than 5. At most 5. And let me look over here. I have 2 things in my hand. The first one is probability x greater than n, and this is probability x lesser than or equal to n. It's equal. Lesser than or equal to n is 1 minus q raised to power of n. So let me write over here. Probability x is lesser than or equal to n is 1 minus q raised to power of n. So this is probability at most 5. Probability x is lesser than or equal to 5. Does it fulfill this criteria? The answer is yes, it does. So this is 1 minus 5 over 6 raised to power of 5. We will use a calculator and get the answer. Let me look at the answer. Part B. So that was the first one. 5 over 6 raised to power of 7 into 1 over 6. Probability x less than 6, that is probability x less than or equal to 5, which is 1 minus failure. This is failure. 1 minus failure raised to power of 5. All good? All clear? Or someone who does not know this, he has to work all this thing out. So therefore, it's better that you use these 2 rules, which comes in very, very handy. Probability x greater than n, q raised to power of n. Probability x is less than or equal to n, 1 minus q raised to power of n. Just use it. That's it. But make sure that when you use it, everything matches. If it was, for example, probability x is less than 7. So less than 7, this is 7, this is 6. That would be probability x is less than or equal to 6, and then you would be able to use it. So the inequality should match before you are able to use it. Now it says Ramesh now has, now repeatedly throws two ordinary fair 6-sided dice at the same time. Now there are 2 dice. Each time he adds the 2 numbers that he obtains. For 10 randomly chosen throws of the 2 dice, find the probability Ramesh obtains a total of less than 4 on at least 3 throws. Now, probability, the total, first of all, the total is less than 4. Less than 4 means either it could be 1, it could be 2, it could be 3. But we are dealing with 2 fair 6-sided dice. So that is 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. The minimum total cannot be 1, it could be 2, it could be 3. How can a sum of 2 is obtained? That is by 1, 1. How can a sum of 3 is obtained? That could be 1, 2 and 2, 1. So these are 3 options. These are 3 options out of how many? Out of 6 by 6. 6 by 6 is 36. So probability of getting less than 4 should be what? 3 out of 36 or 1 over 12. All good, all clear? Now, those people who have my WhatsApp, they can ask me if there is any question. Some people who wants to write it down in the comment section, they can. Now, people, don't worry about the timing because I'll be first going over binomial. I'll be going over the questions of binomial with logarithms, and then I'll be doing the DRV. So I've changed the pattern for today's class. So probability less than or equal to 4, that's 1 over 12. Now, how many throws are there? There are 10 throws. So that is the number of trials is given. And that number of trial is 10. So this is N and this 1 over 12 is P. Therefore, Q is 11 over 12. All good, all clear? So now let me just add a page over here. So I'll write X follows a binomial distribution 10, 1 over 12. And what are they asking for? On at least 3 throws, obtains a total of less than 4 on at least 3. So probability X is greater than or equal to 3, which is what? 3, 4, 5, 6, 7, 8, 9, 10, which is too much to calculate, which is 1 minus probability X is less than or equal to 2. So therefore, this is 1 minus, make a big bracket, that is 10C0 with 2 brackets, 10C1 with 2 brackets, and this is also part of the bracket, 10C2 with 2 brackets. So the success is 1 over 12, that's 1 over 12, that's 1 over 12, that's 1 over 12. The failure is 11 over 12, 11 over 12, 11 over 12. And what about the powers? The power of 1 over 12, this is 0, this is 1, this is 2. The power of failure is 10 and 9 and 8. And again, no harm in double checking. The total should add up to 10. 9 plus 1 is 10, 8 plus 2 is 10. Now you would use a calculator and get the answer. So let me show you the working. The working is all over here. Probability of total less than 4 is 3 over 36, 1 over 12. 1 minus probability of 0, 1, 2, that is exactly what we have done. They have given even the intermediate step. If you can write everything in one shot, that is perfectly fine. Just take care of the accuracy, and this is the answer. So now that was a brief overview of binomial and geometric. And now let me show you something related to logarithm and indices and all these things. Something very, very important. We know that when we solve a linear inequality, if the coefficient of x is negative, irrespective of the other side is negative or not, inequality flips. Whenever the coefficient of x is negative in linear inequality, inequality always flips, whether when x is made the subject, irrespective of whether the other side is positive or negative. That's the first thing. Common log, natural log, what happens? If you take log of both sides, the power comes down. Keep that in mind. Now over here, a simple question, find the least integer value of n such that probability such that 0.75 raised to power of n is lesser than 0.05. There is no mention of probability at the moment. So what we do is that we take log of both sides and just ignore this, just focus on this. Take log of both sides. This power comes down. N log 0.75 is log 0.05. When we talk log of any number between 0 and 1, it comes out to be negative. This also comes out to be negative. Since this is the variable, and since this coefficient is negative, therefore the inequality flips. And since we are looking for the least integer value, there are many other integer values greater than 10.42. That's 11, 12, 13, 14, 15, and so on. Which one is the least? That is 11. Just pick the next number. Keep that in mind. Now, there are different type of questions that comes using logs, inequality, and binomial. Remember the 3 words. Logs, inequality, and binomial. It's your choice which log to use. You can either use the log, that is the common log, LG, LOG, or you can use the log, that is natural log, LN. But whatever you do, choose one before the examiner. before the exam actually starts, and that is applicable on both the sides. Now let's look at this question. Now, someone is asking this thing, can you give a quick go through of trigonometry? I don't think so that would be possible. What you can do is that just go through the playlist, and there are many good videos of trigonometry over there. So better you can have a look on that. So right now I'm focusing on this thing. So trigonometry won't be that much possible. Now, the thing is, in a certain country, on average, 1 student in 5 has blue eyes. So what is the probability of success? That is having blue eyes. So for a random selection of n students, the probability that none of the students have blue eyes, has blue eyes, is lesser than 0.001. Find the least possible value of n. We are just interested in the first part. So that is the first part that we are interested in. Probability of blue, that is success. P is 1 over 5, Q is 4 over 5, number of trials is unknown, 1 over 5 is written as 0.2. Probability x is equals to 0. No one has blue eyes. That means they have another different colored eyes except blue. That is 0.8 raised to power of n, because NC0 is 1, 0.2 raised to power of 0 is 1. We are left with this. This probability is lesser than 0.001. 0.8 raised to power of n is lesser than 0.001, and you are back to the basics of logarithm, the basics of inequality. What we do is that we take log of both sides. This power jumps down. Okay? It jumps down. That is the rule with log. And you take log of this number, you take log of this number, and you divide. The inequality flips. Keep that in mind. Why? Because this thing was negative, this thing was negative. The main thing was this thing was negative. As long as the coefficient of variable is negative, inequality flips. Now n is greater than 30.95. Again, draw a small number line. So this is 30, 31, 32, 33, and so on, greater than 30.95. We have the value 31, 32, 33, out of which 31 would be the least one, and therefore the answer is 31. It's not a matter of rounding off. Find the least possible value of n. So there could be a question like this. There could be a question, something, let me just show you, something like this. The probability that the target is hit at least one or once. That is, the probability that the target is hit is 0.3. Find the least number of shots which should be fired if the probability that the target is hit at least once is greater than 0.95. So x follows a binomial distribution n, 0.3. Probability x is equals to 0. That is failure raised to power of n. Probability x greater than or equal to 1. That is 1 minus probability of 0. Remember this rule. Probability of at least one of anything is 1 minus none of that thing. Probability of at least one red card is 1 minus 0 red card. So at least one red, it could be red, it could be red, blue, it could be blue, red. We are talking about 2 cards taken out. So what is the shortcut? A probability, calculate the probability of 0 red, subtract it from 1. That will give you at least one red. So this is what we get. Then we write 1 minus 0.7 raised to power of n is greater than or equal to 0.95, negative 0.7 greater than or equal to negative 0.75. Now this is the first flip. Why? Because you cannot take log of a negative number unless and until it is positive. So this is the first flip. Greater than or equal becomes lesser than or equal. Then it's the same basic thing. Log 0.7 raised to power of n is lesser than or equal to log 0.05. This value is negative. Let me highlight it again. This is negative. This is negative. Therefore, the inequality flips again. So this is the second flip. So remember, when this is a question of at least one or at least once of anything, that is a double flip question. So now this is greater than or equal to 8.39. Again, a number line. So therefore, this is 8, this is 9, this is 10, this is 11, infinity. So greater than 8.39 or even greater than or equal to 8.39, we know that n has to be an integer. So therefore, this is 9, this is 10, this is 11, this 9 is the least, and that is the answer. So that was something about binomial and logs. That was the overview that was needed. Now let me go back to DRV. Now some other questions of DRV. So let's get started with this. This was a strange kind of a question, not difficult, but a little bit strange. Why don't you go ahead and first have a look at this? Think about it. And what are the different scenarios that come to your mind related to this? Now it says in a particular discrete probability distribution, the random variable x, let me just reduce the brightness. The random variable x takes the value 120 over r with probability r over 45. Now this is the strange thing. That is the probability. Random variable x takes the value 120 over r, and the corresponding probability is r over 45, and r itself takes the integer values. R can take all the integers value from 1 to 9 inclusive. Now the first thing that needs to be done is that draw up a big table. So I'll draw a big table, and in the table I'll write down three things. I'll write R, I'll write X, I'll write probability X is equals to X, or X equals to R. X is dependent upon R. So X itself is 120 over R. Let me first write down what is R. This is 1, this is 2, 3, 4, 5, 6, 7, 8, and 9. That's the values of R. Now the corresponding probability is 120 over R. So if X is 120 over R, that's 120 over 1, 120 over 2, 120 over 3, 120 over 4, 120 over 5, 120 over 6, 120 over 7, 120 over 8, and this is 120 over 9. These are the values of X. As simple as this. Just follow the instruction. And then it says the probability is R over 45. So this is 1 over 45. This is 2 over 45. This is 3 over. This is 4 over. This is 5 over. And no need to reduce it. 6 over, 7 over, 8 over, 9 over 45. And don't worry about this, that the probabilities should add up to 1. Yes, they will definitely add up to 1. Otherwise, it won't be a discrete random variable. That's not your headache. Your headache is to follow the instructions in letter and spirit. Okay. So now that is the thing that we will do. Now someone has asked this question that, sir, are you going to do past paper solve streams in the upcoming days? I have this intention. No promises, because I don't want to break any promises. I'll try to do as much as possible. And if you can check the channel, yes, there are some solved past paper questions related to, I think, this current session that was May, June 2024. So yes, I have the intention, and let's hope for the best. So now let's look at the first part. First of all, what I've done, let me explain you one more thing. What I have done is that I have done the second part first. So this is the second part. I have constructed the probability distribution table, and those people who take my classes on a regular basis, they are aware of my nature, that I look at a question, I look at it in totality, and I focus that since it's a DRV question, they would be asking us to form, complete, make a probability distribution table, either partially or completely. And every other thing will be related to this. All good? So now, once I have done the second part, let me move to the next part. What is the next part? Show that probability. So show that probability x is equals to 40 is 1 over 15. Now, where is 40? This 3, this thing, this thing, this is the answer of part 1. This is part 1. When r is 3, x is 120 over 3, or 40, and probability of this x is equals to 40. That's the same thing as probability r is equals to 3 is how much? 3 over 45. What is 3 over 45? Is it that 1 over 15? The answer is yes. Now, just flip the scenario. If I were to think about only part 1, yes, there is a chance that I'll get successful, but that would be distracting me. I have to form the probability distribution table anyway. I have to show all the working. So why shouldn't I go ahead, show all the working, and then go to part 1? Now, the intention of the examiner is very good. The intention of the examiner is they are giving you a value so that you have a certain level of, certainty, a certain level of confidence, a certain level of achievement that yes, you know that this is correct, but my perception is, my perspective is just do the whole thing and then you will get everything correct. Now let me go to the third part. The third part is which is the modal value of x. So now the word modal, that is related with the word mode. Mode is about highest frequency. That is what you have done in O-level maths. And now we are talking about highest probability. So which is the biggest value of probability? The denominators are all the same. 45 is everywhere. That means the biggest denominator will be 1 with the highest value of the numerator. So that would be the biggest probability. So this is 9 over 45. They are asking the modal value of x. The modal value of x is 120 over this thing. So the answer of part 3, x is 120 over 9. Leave the answer as it is. If you want to reduce it a bit, that's perfectly fine. Now let's focus on the fourth part. Now on the fourth part, let me choose this pink color. Find the probability that x lies between 18 and 100. So now probability x lies between 18 and 100. Now think about it. 120 over 9, 120 over 8 is 15. 120 over 9, that is like 12 or something. 120 over 6, that is 120. So let me take out my phone because I have to use the calculator. So 120 divided by 9, that is 13. So this thing is 13.33. And 120 divided by 8, this I know is 15. 120 divided by 7, that is 17. And 120 divided by 6, that is 20. So basically 120 over 7, this is not included, this is not included, this is not included. I am going greater than 7. X is greater than 18, not 7, 17. And this is x is lesser than 100. So let me write it. Probability x lies between, what is next? Greater than 18. Greater than 18 is 120 over 6, which is 20. And what about lesser than 100? This is 120. So this is also out. 120 over 2, that is 60. So that is what we are looking for. That means the answer for part 4 is this thing, this thing, this thing, this thing. These are all the values that we need. So we are looking for these 5 values. That is, it lies between, this is 60 and this is 20. So x lies between 20 and 60, and just use the probability from here. There is no calculation as such involved. It's like getting the info from the table. So let me just open this thing up so that I have everything ready. Okay, so now what I'll do is that just look at the numerator 2, 3, 4, 5 and 6. So that is 2 plus 3 plus 4 plus 5 plus 6 divided by 45. 6 and 4 is 10. 5 plus 5 is 10. So that is 20 over 45. That comes out to be 4 over 9. That is the answer for this part. Now let me show you the working. This working was basic. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 120, 60, 40, 30, 20. This thing, I have left it in the fraction form. This is 40 over 3. That is 13.33. Which answer is that? That is this thing. 120 over 9, that is 40 over 3. That is this particular answer. And this answer is 20 over 45, 4 over 9. No need to write in fractions because no need to write in decimals because fractions are exact and fractions are beautiful. That is the main thing. Now let's look at this question and let me just double check whether the pencil is all charged or not. So now I want you to have a look at this question, go through it, and I think it's getting a little bit warm here. Okay. Okay, now it's all good. It says set A consists of 10 digits. There are some zeros. Let me highlight it. Let me first grab a highlighter, slightly smaller one. Okay, so there are let me make it even smaller. That is 1, 2, 3, 4, 5, 6 zeros. There are 4 zeros over here. There are 3 2s over here. There are 3 2s over here. There is a 4 over here. Okay, all good, all clear? So set A has 6 zeros, 3 4s, and 3 2s, and 1 4. This is set A. Set B, there are 4 zeros and 3 2s over there. Now it says one digit is chosen at random from each set. The random variable x is defined as the sum of these two digits. So let me highlight this. The random variable x is defined as the sum of these two digits. All good? So that's like this. Show that probability x is equals to 2 is this thing and tabulate the probability distribution table of x. So again, my strategy is to work this out and then automatically I'll get this thing. And then other things will come later on. So now, first of all, should I use a tree diagram? Should I use a sample space diagram? I think that's debatable. Anything that makes sense to you. What I'll do is that, let me first think. There are 10 options over here. 6, 3, 1 is 10. There are 7 options over here. So 10 into 7 is 70 options. That is the first thing. So first of all, I'll write A. There are 10 options, and in B, there are 7 options. So altogether, there are 70 possibilities, 70 options. If I take a 0 from here, a 0 from here, 0 and 0, that will add up to 0. So I can have a sum of 0. Similarly, 0 and 2 will give me 2, 2 and 0 will give me 2, 2 and 2 will give me 4, 4 and 0 will give me 4, 4 and 2 will give me 6. Okay, so sum of 0, sum of 2, sum of 4, and sum of 6. I think that's about it. Now, let me write over here. Hold for a second. So let me write over here set A, set B. And yahan pe, over here, I'll write all the possibilities. Okay, so zeros, there are 6 and 4. So let me choose the right color. So that is 6 zeros and 4 zeros. So 6 zeros and 4 zeros. So let me write over here 6 into 4. That comes out to be 24 possibilities. And let me just shift this thing a little bit to the side. Little bit more. First of all, this thing. And then over here, I'll write the probability at the end. So sum of 2's, it could be 0, 2, it could be 2, 0. So it could be 0, 2, let me make it bigger. So it could be 0 and then 2 and then 2 and 0. So over here, this is 0, this is 0, this is 2, this is 2. Okay, that looks beautiful. So how many zeros are there? 6. And how many 2's are in the opposite? 3. So this is 6 and 3. That is 18. And how many 2's are there? 3 and 4. So that's 3 and 4. That is 12. So altogether, that is 30 possibilities. Do you get the idea how I got it? I took these 6, I multiply with the 2's. I took these 4, I multiply with the 2's. So 6 into 3 is 18, 4 into 3 is 12. Altogether, it's 30. That's how you get a sum of 2. All good, all clear? Let me just choose the blue color from here. So these are the 2's and this is the green. Now, what else do I need? I need a sum of 4. So I can have the blue and the blue. That will give me a 4, or this 4 and this 0. So blue, blue and green, red. So over here, let me write blue, blue and green and red. How many blue, blue are there? That is 3 and 3. So that's 3 and 3. That is 9. And what about these two? That is 1 and 3. That's 1 and 3. That is 3. Altogether, that is 12. Got the idea? Now, what about the sum of 6? How can I get a 6? I can get a green, I can get a blue. So green and blue, that's 1 into 3. So 1 into 3, that is green and blue. So this is green from here, this is blue from here, this is 1 from here, this is 3 from here, that comes out to be 3. Now, have I taken care of all the possibilities? I'm not very sure. So let me double check. There should be 70 possibilities. So this is a total of 0, this is 2, this is 2 and 2 is 4, 4 and 0 is also there, okay? And then the last one, that is 4 and 2, that is 6. So I think it should add up. Otherwise, if it does not add up, that means I have missed something out. So 24, 30 and 3. So this is 24, this is 3, this is 3 and 12 is 15, 15 and 30. That is 45, 45 and 24. So let me double check. 6 and 4 is 24. That is 6 and 4 is 24. All good? One possibility is left. So 1 into 4 is zeros. Let me just double check. The next one, sum of 2, that's 6 into 3. Sum of 2, that is 6 into 3, that is 18. This is 3 into 4, that is 12. That is all good. And what about this thing? Sum of 4, 3 into 3. Sum of 4, that's 3 and 3, that's 9. And this is 4 and zeros, 1 into 4. In sum of 4, that's 1 into 4. I think I wrote 3, so let me correct it. Okay, now someone I think gave me this thing. So 9 and 4 is 13. I think that was the possibility that was left. And let me double check. So 13 plus 3 is 16. 16 plus 24 is 40. 40 plus 30 is 70. And those who told me, thank you very much. Yes, perfect. So now all together, the total is 70. Now the probabilities, 24 over 70, 30 over 70, 13 over 70, 3 over 70. The sum of probabilities should add up to 1. The sum of possibilities should add up to 70. So tabulate the probability distribution table for X. So if I draw a table over here, so what do I need? I need the values. So therefore, this is X, this is probability, this is 0, 2, 4, 6. 0, 2, 4, and 6. That is 24, 30. 24, 30. The next one, 13 and 3. 13 and 3, everything divided by 70. Now, what about this thing? Show that probability x is equals to 2 is 3 over 7. So this is the answer of part 1. 3 over 7 is actually 30 over 70. So again, I have proven the point that it's much easier to do the tabulation first. The third part, let me go to the fourth part first. Or let me do the third part. 24, 30, 13, and 3. Let me just go to the next page. And I also need this thing over here. Okay, and I also need the table that is 24, 30, 13, and 3. So that is 24, 30, 13, and 3. So let me just fill this up. So this is X, this is P, this is 0, 2, 4, 6, 24, 30, 13, and 3. Divided by 70, divided by 70, divided by 70, divided by 70. So the third part, that is expectation. And let me also make a column for x squared. This is 0, 4, 16, and 36. Expectation of x, that is sigma px, that is 0 into 24, 4 into 30, and that is 0 into 24, and then 2 into 30. 2 into 30 and 4 into 13 and 6 into 3, everything added together divided by 70. Similarly, expectation of x squared, that is based upon this thing, x squared. So that is 0, 4, 16, and 36. That is sigma px squared, that is 0 into 24, 4 into 30. That is 16 into 13, 36 into 3, everything added together divided by 70. So now it's easier to multiply this way because they all have a common denominator. So just divide once by this. Now, what is left? Variance. Variance of x, that is expectation of x squared, minus square of expectation of x. So this is expectation of x, we have to square it. So let me just go to the answer. I'll just show you that is 24, 30, 13, and 3. That is perfect. And these are the answers over here. So that is all mathematical calculation, which I leave up to you. Now comes the last and the most interesting part. That is, given that x is equals to 2, find the probability the digit chosen from set A was 2. So let me write over here, part 4. And let me draw a line. What is given? Given that probability x is equals to 2. So this is the thing. That means we have 18, we have 12, that is 18 over 30 and 12 over 30. And this is red is which color? Red is 0 and 2. So this is 0, 2 combination. So this is 0 and 2 combination, and this is 2 and 0 combo. That's how you get a 2. So let me focus over here. This is the 0 from A, 2 from B, or 2 from A and 0 from B. So remember, blue is 2 and red is 0. Find the probability digit chosen from set A was 2. So set A was 2, that is this one. The blue one is 2. So therefore, there are 12 possibilities. So therefore, 12 over 30. This is A, this is B, this is A, this is B. This is what they are asking to put at the top. And let me just reduce the thing, length of this line. And therefore, this comes out to be 12 over 30 divided by this is not 30, this is 70, my bad. I think I should have turned on the AC. So this is 70, this is 70, this is 70, this is 12 over 70 divided by 30 over 70. So therefore, this is 12 over 30. 6 2s are, 6 5s are, 2 over 5 should be the answer. 0.4 is the same thing as 2 over 5. And that is the answer over here. So that was another nice question that we did. Now, another question, and won't be focusing on the variance, that wastes a lot of time. Just go through this big question and then I'll break it up into different parts. So the variance thing, I'll just skip that. Now it says a player by the name of Sanket, let me highlight it. Sanket plays a game using a bias die, which is, now this is important, twice as likely to land on an even number as on an odd number. The probabilities for 3 even numbers are all equal. The probabilities for the 3 odd numbers are all equal. The first part, find the probability of throwing an odd number with this die. That is the first thing. Okay. So let me start over here. The first part, I can do it over here. It says even is more likely twice to land on an even as on an odd. So let me do it in 2 ways. Method 1. This is part 1, and then over here part 2, method 2. Even versus odd. Even is 2, odd is 1. That is the ratio of even and odd. Probability of even, that is 2 over 2 plus 1, which is 2/3. Probability of odd, that is 1 over 2 plus 1, which is 1 over 3. All good, all clear? Now, how many even numbers are there? Yes, it's a die, and it's a normal 6-phase die. If nothing is mentioned, that is the normal die that we talked about. So there are even, that is 2, 4, and 6. So probability of 2, probability of 4, probability of 6, that's all equal. That is 2 over 3 divided by 3, which is 2 over 9 each. Probability of 1, and odd is 1, 3, 5. Probability of 1, probability of 3, probability of 5. Let me write this P properly. That is probability of 1, 3, and 5 is 1/3 divided by 3, which comes out to be 1 over 9. What are they asking? Find the probability of throwing an odd number. So if we talk about odd, that's 1 over 3. If we talk about even, that is 2 over 3. And then if we talk about an individual thing, that's how it's to be done. Now, what is method number 2? Method number 2 is 1, 3, and 5, and 2, and 4, and 6. The probability of odd, if it's 1, the probability of even is twice. Make sense? It's twice as likely. So now add this up. 1, let me choose a purple marker. This is 1, this is 2, this is 1, this is 2, this is 1, this is 2. That adds up to 9. That means probability of 1 is 1 over 9. Probability of 3 is also 1 over 9. Probability of 5 is also 1 over 9. Whereas probability of 2 is 2 over 9. Probability of 4 is 2 over 9. Probability of 6 is this thing. So now we can total it up. Odd, that's 1 over 9 plus 1 over 9 plus 1 over 9, which is 3 over 9, which is 1/3. Probability of even, that's 2 over 9 plus 2 over 9 plus 2 over 9, which is 6 over 9, which is 2/3. Make sense? So these are 2 different approaches only for the first one, and that is very, very important for 2 marks, but the concept was very much in depth. Now it says, Sanket throws the die once. Now let's get started with this. Sanket throws the die once and calculate his score by the following methods. Now there are 2 ways of calculating the score. If the number thrown is 3 or less, he multiplies the number thrown by 3 and adds 1. That means, let's say if this red score is A and let me call it X. Let me first read it and then I'll figure it out for you. The second thing, if the number thrown is more than 3, he multiplies the number thrown by 2 and subtracts 1. And the random variable X is Sanket's score. Show that probability X is equals to 8 is 2 over 9. Now, how should I proceed with this? If I talk about the red thing, so now that is a very big one. Let me just reduce it. I have the red line. I have the blue rule. Now over here, X is equals to multiply by 3, 3A plus 1. So if this number is A, we are multiplying by 3 and adding 1. Or the number thrown is X, that is multiply by 2 and subtract 4. So these are two different options. They are saying X is equals to 8. If 8 is equals to 3A plus 1, therefore 7 is equals to 3A. A is 7 over 3, which is a fraction which is not possible on a die. How can you get a fraction on a die? You have the numbers 1, 2, 3, 4, 5, 6. Very technical question. And if X is 8, 2X minus 4, therefore 12 is equals to 2X. Therefore X comes out to be 6. Yes, that's the only possibility. That means not X. Let me just change the number over here. Like we have used something over there. Let me just change it. Instead of X, let me just rewrite it again. So instead of X, let me choose another thing. That is X equals to 2B minus 4. So if X is 8, 8 is 2B minus 4. 12 is equals to 2B. Therefore, the score is 12 over 2, which is 6. Can you get a 6 on the dice? Yes. What is the probability of getting a 6 on the dice? I think it's over here. Probability of getting a 6 is 2 over 9. Now it makes sense. Yes, probability of 6 is 2 over 9. And I have proven this part. So all this working is for the second part. All good, all clear? Do watch this part again in the recording. Now the third part, that is useless. I'm not going to waste time on that. The table is there. That is the table. And once the table is there, expectation of X is given, find variance of X. That is normal thing, nothing special. And now let me just copy this table because I'll be needing it for the second part. So take a screenshot and copy this thing. And let me go to the next page. Okay. Now it says, Sanket throws the die twice. Now it's all dependent on this particular table. Sanket throws the die twice. Find the probability. The total of the scores on the two throw is 16 according to this thing. So now we will say the total is 16. How can you get a 16 out of that? I can have the option. There are 3 different options. I can have 8, 8. I can have 6, 10. I can have 10, 6. Got the idea? I take the 8 from here. I take the 8 from here. So X is the score, the total of the scores of the two throws. Now, first of all, what is score? Keep in mind, the random variable X is Sanket's score. What are they asking? Sanket throws the dice, find the probability total of the scores. That means total of two values of X. So in case someone got off the track, that is what they are talking about. So now over here, the total of the two values of X. So now 8 plus 8 is this thing. So that is one option, the 8 and the 8. The second option is 6 and 10. The third option is 10 and 6. How can I get the probabilities for part 4? 8 and 8, that's 2 over 9 into 2 over 9. That comes out to be 4 over 81. 6 and 10, that's 1 over 9. 10 is 1 over 9. Multiply, that is 1 over 81. 10 and 6 is the same, 1 over 9, 1 over 9, that is 1 over 81. The total, do not reduce it, that is 6 over 81. That is the answer for part 4. So let me show you the answer for part 4. All of the parts are there. That is 6 over 81. That's right over here. All good, all clear? That's part 4. Now let's focus on part 5. Part 4 is done, and now we are on part 5. Given, that means conditional probability. Given that the total of the scores on the two throw is 16, so now what I'll do is that I should have the given condition that goes down in the denominator. The total is 16, which is 4 over 81. This is 1 over 81. This is 1 over 81. Always write it separately. So this is from the 8-8 option. This is from the 6-10 option. This is from the 10-6 option. Find the probability. The score on the first throw was 6. So which one is the first throw? That is 6. That is this thing. That is this thing. So therefore 6, 10, this option 1 over 81 goes at the top. So this is 1 over 81 divided by 6 over 81, which comes out to be 1 over 81 into 81 over 6, which comes out to be 1 over 6. And that is the answer for this particular part. So a very, very technical question. And yes, this is from November 2010, variant 61. And those questions were tough. How big was the question? 2 and 2 is 4, 4 and 2 is 6, 6 and 2 is 8, 8 plus 3 is 11. 11 marks out of 50. Yes, that was a very, very big question. So now this thing is done. Let's move ahead and see if there are some other good questions left. I think this is a simple one. Let me just form the equation for you people. This is like a table question. So a table question over here, that is this thing. How many unknowns do you see? 3 unknowns. Now the first thing is that P. So let me highlight this. The first thing over here, that is P plus Q plus R plus 0.4 should add up to 1. So the first thing, that is P plus Q plus R plus 0.4 equals to 1. This is equation number 1. Keep it aside. The second equation should be for what it should be for expectation. Expectation of x is 2.3. So that is using x and probability. We will multiply it out. The second thing, expectation of x is sigma px, that is minus 3 into p, 0 into q, 2 into r, 4 into 0.4, and this comes out to be 2.3. That is equation number 2. The third thing, let me form a line for the third one. That is x square. That is 9, 0, and 4, and 16. That means over here, the third equation, let me just give some gap and write it. That is expectation of x square, that is sigma px square. So that is 3 variance of x is given. Now let me do one thing. Variance of x is expectation of x square minus square of expectation of x. This is 3.01. This is expectation of x square. This is 2.3 square. So I'm just going to the calculator and let me multiply it out. That is 2.3 into 2.3. That is 5.29 plus 3.01. That comes out to be 8.3. Therefore, expectation of x square is 8.30. So this is useless. Make an equation for expectation of x square. Not useless like in terms of equation, but you use it to find expectation of x square, which is 8.30. So expectation of x square 8.30, that is 9p, that is 0q, that is 4r, that is 16 into 0.4, that is equation number 3. All good, all clear? So now this first equation will be used last. So first let me simplify. 2.3 minus 3p plus 2r plus 1.6. So 2.3 minus 1.6, that comes out to be 0.7. So minus 3p plus 2r is equals to 0.7. So let me highlight this thing in green color. So that is this one. That is equation number 2 simplified. Over here, equation number 3 simplified would be somewhere over here. So now this is 16 into 0.4, 16 into 0.4, that is 6.4, minus 8.3, that is 1.9. So over here, this is 1.9, that is 9p plus 4r. So I have done the subtraction over here, okay? And let me just shift this thing over there. So that thing is done. So this is basically equation 2. This is basically equation 3 refined. And let me take 2 and multiply by 3. So 2.1, that is negative 9p, and 3 into 2 is 6r. Let me add it up. This is 4.0, this is 0, this is 10r, r comes out to be 0.4, not bad. And let me use this one. So 1.9 plus 9p plus 4 into 0.4. 1.9 is equals to 9p plus 1.6. 0.3 is equals to 9p. P is 0.3 over 9. So that is 3 over 90, which comes out to be 1 over 30. So now I found the value. Let me highlight this. I found the value of P. I found the value of R. Now let's go to the first equation. P plus Q plus R is equals to, let me highlight this. So P plus Q plus R equals to 0.6. That is 1 simplified. So P plus Q plus R equals to 0.6. Now what is P? 1 over 30. What is Q? That is unknown. What is R? That is 0.4, that is 0.6. Therefore, 1 over 30 plus Q is 0.2. Q is equals to 0.2 over 30. That is 2 over 300. And that comes out to be 1 over 150, if I'm not mistaken. R is 2/5, P is 1 over 30, Q is 1 over 6. Okay. So 0.6 minus 0.4 is 0.2. 0.2 divided by 30, that is 2 over 100, 1 over this thing. And maybe I think I made a mistake or something. Just double check. So P plus Q plus R is equals to 0.6. R is 0.4. 0.6 minus this thing. I mean, just do the correction over here. And I think I made a mistake over here somewhere. So therefore, I'll get the value of Q, which is 0.2 minus 1 over 30. That is 2 over 10 minus 1 over 30. And that is multiply by 3, multiply by 3. 3, 6 over 30 minus 1 over 30. That is 5 over 30. That is 1 over 6. So I think I got it correct now. So this is 1 over 6. All good, all clear. Okay, G. And I think the last question, this is again the same thing as this. So let's skip this one. Yeah, this is the one that I want to focus on. Question number 29. A pet shop has 6 rabbits and 3 hamsters. So let me highlight it. That is 6 rabbits and 3 hamsters. And 5 of these pets are chosen at random. The random variable X represents the number of hamsters chosen. Now, what exactly do I want to focus over here? I want to focus the idea that if I need a total of 5, there are 6 different possibilities. And we are choosing it from the perspective of hamsters. So 5, 4, 3, 2, 1, 0, 0, 1, 2, 3, 4, and 5. Now, yes, there are some options which won't exist in reality, but go with the flow. Cancel them later on. There are 3 hamsters. So this is possible, this is possible, this is possible, this is possible. The last 2 are not possible. So slash this off, slash this off. Now, again, this is like a combination question. Show that the probability and draw up the probability distribution table for X. Again, my focus will be on second part. So let me write down the number of ways. That is 6C5, rabbit from rabbit, hamster from hamster into 3C0. This comes out to be 6C4 into 3C1. 6C4 is 6C2, 6C2 is 15, 15 into 3 is 45. You can use a calculator. 6C3, 654, 321, 20, 20 into 3C2. 3C2 is this thing, that comes out to be 60. And this is 6C2 into 3C3, 6C2, I think it's 15. So let's add it all up. So 60 plus 60, 120, 126. This comes out to be 126. Just go ahead and double check. Now, the probability. This is 0 hamster. So probability X is equals to 0. By the way, what is X? X is the number of hamsters chosen. Probability X is equals to 0, 6 over 126. Probability X is equals to 1, that is 45 over 126. Probability X is equals to 2, that is 60 over 126. And probability X is equals to 3, that is 15 over 126. Now, which one have they given us? Show that the probability of exactly 2 hamsters is this thing. So this is 2 hamster, this is second part, actually the first part. So this is the first part over here. So probability X is equals to 2, that is 60 over 126. And they have written 10 over this thing. So divide by 6, divide by 6. So this 60 over 6 is 10. 126 over 6 is 21. Therefore, the answer is 10 over 21. That is the answer for the first part. So I think there it is, 60 over 126. That's the first part, and all the other options are given. 6 over, 45 over, 15 over, 60 over, that's all given. So I think that's about it. I think a good night's sleep would be a good idea. So we have done a thorough idea of, let me just open this up, a thorough analysis of DRV, discrete random variable. Read the question, decide on the pattern, what exactly needs to be done. So let me just stop the share, I think. Okay. So now then it's either permutation combination, it's either probability, it's either counting principle, all those things, they come in handy. So don't overthink, but at the same time, don't underestimate thinking. Follow the instruction. Look at the minute details. If it's about probability distribution, just go ahead and draw the table. And something that was asked early on, you would prove it during the process. So that's all from my side. I wish you the best of luck for your upcoming exams and stay tuned. Keep in touch. Take care. Allah Hafiz.